So forces in general. You can associate forces with accelerations. So forces are also, you can consider them pushes and pulls, but when you sum the forces, there's always ends up being an acceleration if the forces do not sum to equal 0, but if the forces do sum to equal 0, then there's no acceleration. So if we just consider a person or a car or just something in general, and just say it's a point. Let's say that this is a person, for example. If somebody's pushing on this person, actually, first of all, the most basic of forces, there's gravity force, assuming this person is standing on Earth. The person is standing on the Earth. The gravity force. The weight is equal to the mass times acceleration, which is g, which is 9.81 meters per second squared in metric units. There's also a normal force up because the person is standing on the Earth, so that surface is pushing back on the person to keep the forces in equilibrium in the y direction, assuming this is our y direction and this is our x direction as we define the coordinate system. And this is supposed to be perfectly straight up, and this is perfectly straight down. And these are equal to one another, assuming the person is not accelerating up or down. So, now, say there's another person that's right next to this person, and they're pushing on this person this way. Then, say there's a force this way, because the force of the push. I'm just going to label this force normal, which is perpendicular to the surface that the person is standing on. If the person was standing on a surface like this, then the force would be this way, because it's perpendicular. But in this case, it's just straight up, because it's perpendicular. The weight is down, the weight is down. So in this case, if there's a person, going back to our regular situation where he's standing straight, there's a force push because there's a person next to him pushing him that direction. Then, you'd assume that there's an acceleration in that direction as well, assuming there's no force this way. But say he's resisting this push with a little bit of a push back himself, but not quite as much. Just a little push. F push little. Well, what do you suppose we can do to find the acceleration? Say this is 10 newtons. And this is 2 newtons, maybe. Just a little resistance that he's having. We can sum the forces in our x direction from our coordinate system. And sum of the forces equal to max in the x direction. And this is our mass of the person that we got. Say a mass of a person. Say he's like a really tiny dude. Say he's like 2 kilograms. He's like a little gnome or something. And then we have to sum the forces up. So sum of the forces in the x direction is equal to 10 newtons in the right direction. We're just going to say that the right direction is positive. And minus 2 newtons in the opposite direction. So the total net force is 8 newtons in the right direction, which is equal to, say, 2 kilograms, just for simplicity, times his acceleration in the x direction. So how do we solve for this acceleration in the x direction? Because of its mass being 2 kilograms and the net force being 8 newtons in the positive rightward direction, because of our coordinate system in the right direction, acceleration in the x direction is just 4 meters per second squared, because the units cancel out that way. This is a very simple example, but just help you with a little intuition into figuring out how to do some of the forces problems and other free body diagram problems. But the main idea is draw your free body diagram first and think about what kind of forces would occur. I think the one that people get confused about a lot is the normal force. This is not the Newton pair to the weight, because the Newton pair is equal and opposite force. It's the equal and opposite force Newton pair that is in this problem. This is a portion of the Newton pair. The other portion of that Newton pair would be the Earth itself, which is this equal force that the person is exerting on the Earth. So these are the Newton pair, not the normal force and the weight. These are not Newton pairs, but they happen to be equal in this case. Because in this case, because we said these were equal, the sum of the forces in the y direction are 0. And when we assume that, we also assume that the acceleration is 0. So there's no acceleration in the y direction as we defined it. But there is in the x direction because of this person that's pushing. So I hope this helped you conceptualize some force problems. And thank you for listening. And please subscribe.